Okay, on for another video. We are doing 14, 15, 17, and 18. So number 16 will be part of the last video. Or for another week, or for the same week. I don't know, whenever that gets posted. Anyway, so it says to use Pythagorean theorem, and then to find the length of the missing side, and then find the exact value of the 6 trigonometric functions of the given angle. So that actually goes with February 20th, the Pythagorean theorem, and February 21st, which was the 6 trig functions. Okay, so those are the notes that you can refer to for this, for these problems. So for number 14, if you notice, we have this side and this side both have numbers, and this side is the missing side. Now, the Pythagorean theorem is a squared plus b squared equals c squared. So the c is the important side. So the c is the one that the right angle points to. So that means this side is c, and the other two are a and b. It doesn't matter the order. So I have 4 squared plus 1 squared equals c squared. Here, let me put this on just document camera so I'm a little less distracted. And it shows up better anyway. So that is 16 plus 1 equals c squared, which is 17 equals c squared. So that means c equals the square root of 17. We just need the positive version of that. Remember, plus or minus usually when we square root both sides, but since we're doing the length, we just need the positive. And then we need to do the 6 trig functions. So sine, cosine, tangent, cosecant, secant, and cotangent. Okay. So this is radical 17 now. Sine of theta, it's opposite, if you remember, sine, cosine, tangent, opposite over hypotenuse. So wherever theta is, remember, opposite is across the street, adjacent is next door, and either one of them is the hypotenuse. So when I label my sides, I have my hypotenuse. Since theta is right here across the street, oops, sorry, I just realized. Okay, across the street would be here, so this is opposite, and this is adjacent. So when I do my sine, it is opposite over hypotenuse. Okay. Opposite 1 over radical 17. So I have to fix that, radical 17 upstairs, and then a whole 17 downstairs. Now the cosecant is the flip of that. I could flip either one, but I want to flip the easier one. So I get radical 17 over 1, which is the same as just radical 17. Cosine is adjacent over hypotenuse. Adjacent is 4. So we have 4 over radical 17, which when we fix that is 4 radical 17 over 17. Remember, radical moves upstairs, becomes whole downstairs. And I can flip whichever one I want, but I want to flip the one with the least amount of work. So radical 17 over 4. Tangent, opposite over adjacent. Opposite is 1, adjacent is 4. So 1 over 4. Cotangent would be 4 over 1, or just 4. Both of those answers would be on the test. So when it's scored, if you write 4 over 1, that's fine. If you write 4, that's fine. If you write radical 17 over 1, that's fine. Or just radical 17, that's fine. Okay, number 15, doing the same thing, except this time, if you notice, the missing side is right here. The right angle points to the 7. This is your C. which means we'll call this A, and this one will be B. So if I do A squared plus B squared equals C squared, that is, well, I'll keep A squared as A squared because that's my variable, plus 2 squared equals 7 squared. Okay, got to subtract 4 on both sides, so I get A squared equals 45. 45, I can break that up. We want exact value, which means no decimals. So 45 is 9 times 5, and that is 3 and 3. So those break out. So when I did the square root on both sides, those break out, and I get a whole 3 and a radical 5 left behind. So I didn't show the work really well. That's the work here. I subtract 4 on both sides. That's what happened to get that. And then I square rooted both sides, and I need okay. So now that I have that, I need to find the 6 trig functions. I spaced it out a little bit more this time, just in case I need to show some work because I didn't leave a lot of space on the first problem. So sine. Oh, well, before I do sine, I have to label my sides. Theta is here, which means opposite is across the street. Hypotenuse stays the hypotenuse, across the street, and then next door neighbor. So sine, opposites over hypotenuse, so that's 2 over 7. I'm going to get my right color. Okay. And then when I flip that, 7 over 2. Easy peasy for those ones. Cosine is adjacent over hypotenuse, so that is 3 radical 5 over the hypotenuse, which is 7. So that means when I flip that, I only multiply top and bottom by radical 5, not the whole 3 radical 5. So the radical moves upstairs and becomes a whole 5 downstairs. So we have a little bit of multiplying to do. 7 radical 5 over 15. Tangent, TOA, remember T-O-A, O-A, opposite over adjacent. So that's 2 over 3 radical 5. Move the radical upstairs, so that's 2 radical 5 over 3 times the whole 5. So that is 2 radical 5 over 15. And then cotangent is easy because I'm going to flip that one. 3 radical 5 over 2 would be the answer for cotangent. Okay, I'm going to skip number 16 for now. Numbers 17 and 18. Now let me redo this. So, there. 17. Here we have a helicopter. I don't know how to draw a helicopter. I'm really bad at drawing. You guys know that. So here's my helicopter. I'll just H for helicopter. There we go. Dot. Flying at an altitude of 1,000 feet. So that means straight down is 1,000 feet. The pilot spots a fire ahead at a 52.7 degree angle. So my fire is right there. The helicopter is looking at the fire, so that's called line of sight. And if you remember, angle of depression goes down from the top. So this is 52.7. Let me extend this a little bit more. Okay. It says, what is the ground distance from the helicopter to the fire? So actually, ground distance Helicopter is right here, right above this spot. The ground is right here. Okay. And we need to find the ground distance. Now, we have this 52.7 degree angle, which is not in here, but if you remember, alternate interior angles are congruent. So the angle on the top here is going to be the same as its alternate interior angle, 52.7 right there. So, and then ground, we'll just call it G. Okay, so the sides that we label are the only sides that we have. Well, we know this is the hypotenuse, but we don't have anything on the hypotenuse. Opposite is the 1000. So that's O for opposite or opposite, OPP. And then the ground, which is our adjacent side. So that's hypotenuse, that's opposite, that is ad. Okay, so what I have 1000, which is O, and I have the ground that I need to find, which is A for adjacent. O and A go together for tangent. So I set that up. Tangent of 52.7 equals O over A. So 1000 over ground. G for ground. We can't have G in the denominator, so we multiply both sides by G. So then we get G times tangent of 52.7 equals 1000. We still need to get the G alone, so we would divide by the whole tangent, not just the word tangent, but tangent of 52.7, because that tangent is not separate and that 52.7 is not separate. They go together. So now we can figure out what G equals. We need to put it in the calculator. Okay, so my calculator that I have here at home is the iPhone type calculator. So I type in 1000, and I'm going to divide sign. That's the fraction bar. And then tangent of 52.7, I can't just type the word tangent. I have to do 52.7 and press tangent. Oh. Okay, so I'm learning something new. I'm going to redo this because apparently this calculator is a little bit different. So 1000 divided by, and this one pops up with the word tangent. So that's kind of nice. 52.7 equals 761. So it says to the nearest tenth. So the nearest tenth, well, 761 points, and tenth is one number after the decimal, which is a 7 here, but the 9 makes it an 8.8. There's that problem. And then number 18, the last one we're going to do for this video. How long is the wire from a 25-foot pole to a point on the ground? So there's a pole. It's 25 feet. Now we have the ground. There is a wire going from the top of the pole to the ground to support it. Oh, there we go. And then the pole and the ground hopefully make a right angle, because that's just good construction. So how long is the wire from a 25-foot pole? So how long is the wire? The wire is this line. To a point on the ground that is 6 feet from the foot of the pole. Well, here's the foot of the pole. This is the point on the ground the wire touches. So that means this is 6 feet. Okay, and if you notice, we're not dealing with angles, so we don't have to worry about trigonometry here, we just have to worry about Pythagorean theorem. The right angle, remember, points to our C. In this case, I called it X. And then these are A and B. It doesn't matter which is which. So A squared plus B squared equals C squared. Plug it in. Okay, I think my orange is getting low. 25 squared plus 6 squared equals X squared. So 25 squared, 25 times 25 is 625, plus 36 equals X squared. So 625, I don't want to get it wrong, so I'm just going to do this. 625 plus 36, 661. Okay, so square root both sides, and since it says to the nearest tenth, I don't have to find what breaks out. I just have to put that in here. So 661, and then I square root it. I have my 661 on here. For me, square rooting is the inverse in I and V. I have to press this like second, and then this. And so I have my square root, 661, and so it's 25.7. The 0 means that the 7 does not round up. So 25.7 feet equals X. And there we go. So this is the last problem for that video. The next video, I will deal with this problem, which I know I've gotten some emails on. Have a good day.